Welcome to Biology My Passion. I am Soumya Harikrishna. Today we are going to learn another chapter in chemistry class 9, atoms and molecules. Dalton gave the confirmation for the law of definite proportion. Actually, along with that, he gave a very bold concept of atomic mass also. So after this, many scientists became so curious to know about mass of atom, because atom also should have some mass. But was it easy to find out the mass? Absolutely not. Why? Because atoms are very small particles. We cannot even see them, then how can we weigh them? It was very difficult. But they knew that the different elements or the atoms of different elements are combining in definite proportion to make a substance or a compound. For example, carbon monoxide, if you take, it has two atoms, carbon and oxygen. They found that 3 grams of carbon should combine with the 4 grams of oxygen to make carbon monoxide. So if you compare, 3 by 4th of the mass of oxygen is the mass of carbon. So like that they started finding out the relative mass, not the absolute correct one, but at least the relative mass they started finding out, and they used the unit AMU. AMU stands for atomic mass unit. But later IUPAC intervened and recommended, okay, we will use only U, unified mass. Suppose now I say carbon has atomic mass 12U. I don't have to say 12 AMU. AMU is also correct, but now we use only 12U. Initially, they wanted some parameter for measuring the atomic mass. For example, when you are going for, you must have seen at least the recruitment in military and all. So they do not have every person, we cannot measure he is 172, another person 168, another person 158, another person 155. So it is a very difficult task when hundreds of people are there for recruitment process. So candidates are there. So in such cases, they keep a bar. They will start them to walk through. So if you are hitting, or it's a rope, so when you are walking, if your head is hitting, that means, or touching, that means you are above that, right? So you are selected. But if you are easily passing through that, your height is less than that, you are eliminated. So that's an easy way of doing that. So there we are comparing your height with the benchmark they have set above or below. Okay, the same way they also did using that. Or another example, if I say, when you are doing cookery, right? Some channels, if you see the cookery show, they will tell you have to take 12 grams of or one measuring cup full of the rice, and you have to take 3 cups of and all. So sometimes we may not have the weighing machine. Some people tell with the correct weighing machine balance. So everybody may not have the weighing balance at home, or in the kitchen we usually don't use that. We don't measure the components. But if they are telling the whatever cup you are, and you don't have a measuring cup also, because we get it for buying that half cup, quarter cup and all, measuring cups are there. But even that we don't have. Some people, they simplify it and tell us, you take whatever cup you are taking. Suppose I am taking a glass in my house as a measuring cup. 1 cup of that, if I add, 3 cups of water you add. Finish. So I can take any of that vessels available with me, but that quantity ratio they are telling. So it's easy for me, right? So initially the scientists also wanted some parameter to compare. So they initially took oxygen mass, and they found 116 the mass of oxygen. Whatever is the value of 116 mass of oxygen. For example, if I take it as X, okay, X unit is the 116 the mass of oxygen. Then if I say the hydrogen has 1 XU, means what? Hydrogen is equal to 1/16th of mass of oxygen. So they were comparing using oxygen. Why oxygen was chosen? So many elements are there. What is special about oxygen? There are 2 reasons for that. First of all, oxygen reacted with almost all other elements, and it was easy for them to find out the proportion by mass. Okay, that was one reason. Second, when they were calculating this, mostly they got whole numbers. So we want whole numbers, its calculation is easy, right? It's not that 0.5 or 0.73 added like that. So these were the 2 reasons why oxygen was selected. But later IUPAC recommended in 1961, the recommendation came that instead of this oxygen, we can take the weight of carbon 12 isotope. So 1 by 12th mass of carbon 12. For example, carbon 12, it is 12 unit. So 1 by 12th of 1, this is 1 unit, right? So that is the parameter now we are using as a standard measuring parameter. So suppose now hydrogen is 1 unit, means what? Hydrogen has a mass equivalent to 1 by 12th of mass of a carbon 12 isotope. Helium is suppose 2 unit. If I say helium has a mass equal to 2 by 12. Helium has 1 by 12th of mass of isotope, 2 times it is calculated. In your textbook there is an analogy given, that is if a fruit seller, he doesn't have a weighing machine. For example, weight is not there. Somebody is asking for half kg of potato, another person asking about quarter kg of tomato, but he doesn't have his weight. So what he does is, he has the suppose a watermelon. This watermelon is considered as a carbon 12. Okay, it is divided into 12 parts. Okay, so each part weighs 1 by 12 of the total mass. So watermelon is considered carbon 12. We are taking 1 by 12th of the mass, and somebody is coming for a 2 parts of this tomato. So he will keep 2 pieces of that, equivalent to that tomato he will give. Another person, he will keep 4 pieces of that, that is 4 by 12, and then that equivalent amount of potato will be given. So this one piece is the parameter for comparing, measuring. So accordingly we can use. In this table you can see atomic masses of few elements. First is a hydrogen, it's a 1, that means it's 1 by 12th of the mass of a carbon 12 isotope. Carbon 12, that means 12 by 12. Nitrogen is more than that, that is 1 by 12 by 12 plus 2 we have to add. Oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35.5, calcium 40.